So today we discuss the previous year question of 2015 assistant engineer, assistant executive engineer, paper 2. In the previous lecture we solved paper 1, and in this class we try to solve the paper 2 of 2015 AEE mechanical paper. So the first question is, the following is not a true in case of thermodynamics work. So options are W is equal to PdV for reversible process only, and W is equal to 0 if change in volume is equal to 0, and W is not equal to PdV integration of for a free expansion process, and W is an inexact differential. And the question asks which is not a true in case of thermodynamics. So the answer will be W is not equal to PdV for a free expansion process. So this is not a true. Next question. The internal energy of an ideal gas is a function of pressure only, volume only, absolute temperature only, pressure, volume, and temperature only. So internal energy of ideal gas is a function of absolute temperature only. So option C is the correct answer. Next question. During a certain compression process, 1 kilojoule of mechanical work input is supplied to the 2 kg of gas enclosed in a cylinder piston assembly, and 400 joule of heat is rejected during cooling water being circulated in the jacket encasing the cylinder. And this brings out the change in the specific internal energy. So 1 kilojoule of mechanical work input is supplied. So from first law we know dq is equal to du plus dw. So 1 kilojoule of mechanical work is input. So work done on the system. So this is negative work. This is 1 kilojoule, and we have to find the internal energy. And 400 joule of heat is rejected. So this is rejected is negative sign. So 400, let's convert into kilojoule. So answer will be in joule. So first convert 1 kilojoule to into joule. So this is 1000 joule, and this is 400. So change in internal energy is 1000 minus 400, which is equal to 600 joule, and this is for kg. So divided by 2 equal to 300 joule per kg. Answer will be option C, 300 joule per kg inverse. Next, question number 4. The correct statement regarding entropy is a path function. Entropy can be obtained from direct measurement of Q and T. During a change of state of a system, the entropy change is the same whether that change has occurred by a reversible process or an irreversible process. And then 20, entropy of an isolated system is 0. So the right answer will be, during a change of a state of a system, entropy change is the same whether that change has occurred by reversible or irreversible. Next, question number 5. One Carnot heat engine operated between 1600 Kelvin and temperature T2, while the operating between T2 and 400 Kelvin. Both have same heat input and heat rejected then T2 will be. So let's draw the diagram. This is 1600 Kelvin and this is one engine which produces work, and this is the intermediate temperature which is T2, and which are also one cannot heat engine. This is produce some work and some reject. It is 400 Kelvin. We have to find the T2 temperature. So given that same heat input and same heat rejection, so this Q1 and this is Q2 and this also Q1 and this also Q2. So first law, Q1 is equal to W, this W1 and this is W2, W1 plus Q2. And from second engine, this is first engine, then this is second engine. For second engine, Q1 is equal to W2 plus Q2. So this equation same when W1 is equal to W2. So we can get W1 is equal to W2. Next we have to found, let's erase it. Efficiency we know W divided by Q1 first engine. So it will be so then this is for first engine, which is efficiency 1 is equal to W1 divided by Q1. So W1 is equal to W2. So let's equate for W1 and W2 for first engine and second engine. So efficiency 1 into Q1 is equal to, then efficiency 2 of second engine equal to W2 divided by Q2. Sorry, Q1 as Q1 is equal to Q2, and this is Q1 also heat input. So this is Q1 and which is equal to efficiency into Q1. So Q1 cancel and efficiency 1 is equal to efficiency 2. So efficiency 1 of first engine is equal to T higher minus T lower divided by T higher. So 1600 minus T2 divided by 1600, which is equal to, for second engine, higher is equal to T2 minus 400 divided by T2. So solving this, 1600 T2 minus T2 square is equal to 1600 T2 minus 6440. So 1600 to 1602 cancels, minus cancel. So T2 is equal to root over of 6440. So this is 800 Kelvin. So answer will be 800 Kelvin. Next, question number 6. Gasol is a mixture of 10% ethanol and 90% gasoline. Next, question number 7. Disadvantage of hydrogen as a fuel in IC engine. So disadvantage Disadvantage of hydrogen as a fuel in IC engine is detonating tendency. Next, question number 8. Major constituent of natural gas. Natural gas major constituent is methane. Option B is correct. Next, major disadvantage advantage of LPG as a fuel in automobile is less power compared to gasoline. Option B is the correct. Next, question number 10. The method of governing for a petrol engine is quantity governing. Option C is the correct answer. Next, fuel is injected in 4-stroke SI engine. Fuel is injected in a 4-stroke SI engine is at the end of compression stroke. Option B is the correct answer. Next, main advantage of Pintox nozzle is better cold starting performance. Next, question number 13. With an increase in compression ratio, flame speed increases. Next, scavenging means using air for throwing burnt gas out of the cylinder during exhaust stroke. Option C is the correct answer. Next, at flash point temperature, fuel emits vapor which produces an inflammable mixture with air. Option B is the correct answer. Next, C10 number is the measure of delay period. Option A is the correct answer. Next, if diesel is fed into petrol engine, then the engine will not run. Next, question number 18. This question is also very important for the exam point of view. If diesel is fed into petrol engine, then engine will be not run. Next, between the time of injection and time of ignition in a diesel engine is called as delay period. Option B is correct answer. If the compression ratio is kept same, then the thermal efficiency. Otto cycle is less than dual cycle. Otto cycle is same as the diesel cycle. Otto cycle is less than the diesel cycle. Otto cycle is more than the diesel cycle. So let's draw the PV diagram. This is for Otto cycle, constant volume intake and constant volume rejection process, and the compression ratio is the point between this and this. This is 1, this is 2. Compression ratio CR is equal to V1 divided by V2. This is volume axis, this is pressure axis. For same compression ratio, this is 1, 2, 3, there's 3, 4. And this is constant pressure heat addition process. This is diesel cycle, and the area represent the network, and by the network we can determine thermal efficiency. So from this area we can conclude 1, 2, 3, 4 area is more than the 1, 2, 3 dash, which is diesel cycle, and this is Otto cycle. So the area of Otto cycle is more, so the network also more. That's why the thermal efficiency of Otto cycle is more than the diesel cycle. So question number 19, option D is the correct answer. Next, question number 20. Stoichiometric ratio means chemically correct air fuel ratio by mass. Option A is the correct answer. Next, the MLT theta system of dimension of the thermal conductivity. So the answer will be ML theta inverse T power minus 3. Next, two planes slab of equal area but with thermal conductivity in the ratio 1:2. So K1 is to K2 equal to 1:2 held together with temperature between the outer surface T1 and T2. And the junction between two surfaces is desired to be, this is T junction, T1 plus T2 divided by 2, and their thickness should be, we know heat conduction is K area del T by thickness. So area is constant and temperature difference is also constant. So K is directly proportional to thickness. So K is related to 1 is to 2, then their thickness will be related to 1 is to 2. So answer will be option A. Next question number 23. Thermal diffusivity of a substance is inversely proportional to thermal conductivity, directly proportional to inversely proportional specificity. So thermal diffusivity alpha is equal to K by rho Cp. So thermal diffusivity is inversely proportional to specific heat at constant pressure, whether thermal conductivity kept constant, so inversely proportional to specific heat. Option C is the correct answer. Next question number 24. If the temperature of a solid surface increase from 27 degrees centigrade to 627 degrees centigrade. So let's just convert it into in Kelvin. So temperature 27 is equal to 300 Kelvin, and this is also 900 Kelvin. So the temperature difference is 600 Kelvin. Okay, then MECB power. Then the MECB power increases in the ratio of. So MEC power is equal to sigma temperature power 4. So epsilon 1 is equal to sigma T1 power 4 and epsilon 2 is equal to sigma T2 power 4. So epsilon 1 by epsilon 2 is equal to sigma T1 power 4 divided by sigma T2 power 4. Sigma sigma is constant cancel, and epsilon 1 by epsilon 2 is equal to T1 given 300 and T2 is given 900, and this is power 4, this is power 4, and this is 300 divided by 900 whole power 4, that means 1 by 3 whole power 4. 1 by 3 whole power 4 is equal to 1 by 3 to the power 4 is equal to 81. Option D is the correct answer. Next, it is desired to reduce the radiation energy exchange between two infinite parallel planes by inserting a radiation shield of same emissivity. The number of shield required for 80% reduction. So 80% reduction, for 80% reduction, we know the formula 1 by n plus 1 is equal to the percentage where we try to reduce divided by what is present heat radiation. So we have to count not the number of shield, that means n. So we have to reduce 80%, that means what remaining 20%. So 20% means 1 by 5, simply 20%, which is equal to 20 by 100. So this is equal to 1 by 5. 1 by 5 is equal to 1 by n plus 1. So what value of n we can equal to 1 by 5, so n will be 4. Option C is the correct answer. Next question number 6. Fin are provided on heat transferring surface to increasing surface area to promote rate of heat transfer. So option A is the correct answer. Next question number 27. If the radius of any current carrying wire is less than the critical radius, then the addition of electrical insulation will enable the wire to carry a higher current because of heat loss from the wire is increased. Next question number 28. An ideal absorber of a radiation is also ideal emitter. This is known as Kirchhoff's law. Next question number 29.
A thin plate is hanging freely in air at 27 degrees centigrade. Solar radiation fall in one side. The rate of heat transfer is 500 watt per meter square. For maintaining the temperature of the plate constant 32 degrees centigrade, value of heat transfer is. So the heat transfer is heat transfer convection constant, and this area and del T. So we have to find H value, and this is thin plate, so taking at 1, and this is Q given 500, and H we have to calculate it, and area and temperature difference is 27 and 32. 32 minus 27, this is 5, so 5 cancel 100, so answer will be 100 watt per meter square. Then Nusselt number in natural convection is function of natural convection. So answer will be Reynolds number and Prandtl number. Sorry, this is natural convection. So this will be Grashof number and Prandtl number, not Reynolds number. Prandtl. Next, LMTD of heat exchanger del T1 del T2 being a temperature difference between hot and cold fluid at entrance and exit. Then LMTD is del T2 minus del T1 divided by log del T2 by del T1. So answer will be option A. This delta 2 is coming fast, so in the log case delta 2 also fast case, so answer will be option A. Next, refrigerant flow is controlled by expansion valve. Option D is the correct answer. In a reverse Carnot refrigeration cycle, and that means Bell convection cycle, the condenser and evaporator are 27 degrees centigrade and 13 degrees centigrade. Then the COP of the cycle. So COP of the cycle, we know refrigeration effect, COP, what input. So for this reverse Carnot cycle, so it is also T lower, so T higher minus T lower divided by T lower. Sorry, 1 minute, I have to derive the formula. So this is the cycle, we have to work input, and this is Q rejected, and this is Q input, and this is the refrigeration effect where T lower and this is T higher. So from the first law, W in plus Q1 is equal to Q2. So refrigeration effect, so W in is equal to Q2 minus Q1, and refrigeration effect is equal to Q1, so it is equal to TL divided by TH minus TL. So the lower temperature is given 27 degrees centigrade, that means 300, this is 300, and minus 13 degree, minus 13 plus 273, 273 minus 13, which is equal to 330, 716, 260 degree, 260 Kelvin. So this is equal to, sorry, the lower temperature is 13 degrees centigrade. So 13 degrees centigrade, that means the lower temperature, we mistakenly taken higher temperature. So the lower temperature is equal to 260 Kelvin, and this is 300 minus 260, which is equal to 260 divided by 40, is equal to 26 divided by 4. This is equal to 6 to 24, 20, so 6.5. So answer will be option A, 6.5. Next question. Using secondary refrigerant in milk chilling unit is ammonia solution, sodium silicate, glycol, brine. Answer will be brine.
Next question number 35. In cooling tower approach, is the temperature difference between cold outlet temperature and wet bulb temperature? Next, a hermetically sealed unit implies that both compressor and motor are sealed. Hermetically means both compressor and motor are at one place, that means sealed. Then the chemical formula of phenon 1 2. So this is phenon, that means R12. That means the designation is Rm-1, N+1 and P. That means R012. That means M-1 is equal to 0 and N+1 is equal to 1 and P is equal to 2. So N+1 is equal to 1, that means N is equal to 0 and M-1 is equal to 0, that means M is equal to 1. So the chemical formula is CmHnF chlorine and chlorine MnPq. And this for we have to found Q. So for finding Q, we know the formula N plus P plus Q is equal to 2m plus 2. So N is 0 and P is equal to 2 plus plus Q have to found, and at M is equal to 1. So M is equal to 1. So 2 into 1 is equal to 2 plus 2 is equal to 4. So Q is equal to 4 minus 2 is equal to 2. So we found all the value. Let's put in the chemical formula. So C M value is 1, H N value is equal to 0, and F chlorine, P value is 2, and Q value means chlorine, Q is equal to 2. So CF2 Cl2, CF2 Cl2, then match the carbon, chlorine 2 and chlorine 2. So option A is the correct answer. Next, question 38. Heating of air without changing its moisture content taking place on the psychometric chart along. So horizontal line of constant dew point. Answer will be option A. Next, question number 39. Dry compression is preferred. Dry compression is preferred for less chance of damage of compressor. Option C is the correct answer. Next, pipe material of refrigerant with ammonia solution as working fluid should not use. So we know ammonia attack copper, so copper should not be used. So answer will be copper. Next, undercooling of refrigerant leads to increase the COP of the cycle, and COP of refrigerator and heat pump is related to. So COP of heat pump is equal to COP of refrigerator plus 1. So option C is the correct answer. Then in the next class we solve from question number 32. So thank you.